days, and that is ionization energy. Now, you should have some familiarity with ionization energy because you created the trend on your little chem trays with the straws. So let's talk about what ionization is. So it is the amount of energy it takes to lose an electron. Our trend for ionization energy is the closer you get to helium, the higher the ionization energy. So in other words, if helium is our highest, that means that as we go from left to right across the periodic table, ionization energy increases. We already took it. Okay. And as we go from the bottom to the top, ionization energy also increases. All right, so that means the opposite would also be true. So if I were going down a family, ionization energy would be decreasing. All right, if I was going from right to left, it would decrease. So those arrows can go either direction. You're just going to flip the trend. So as we're heading towards helium, helium is like our queen of ionization energy. It's got the most ionization energy. Why? So the lab that you guys were doing, or the activity that you guys were doing the last couple of days, asked you questions like why? Based on what we already know about elements and their particles, why do these trends make sense? All right, it's important for you to know why, because that's the kind of questions that they're going to ask you on your exam. So let's look at why ionization energy increases as we move towards helium. It is due to the higher number of valence electrons. So as we move from left to right, our valence electrons are increasing. Remember, your valence electrons are the 1 through 8 numbers that we wrote on your periodic table. All right? 8 is like the perfect number. Okay? So every element wants to have 8 to complete what we call the octet rule. Left to right, we're increasing to 8. All right? Well, ionization energy is the amount of energy it takes to lose an electron. If I want 8 electrons and I have 8 electrons, am I going to just give them up very easily? No. So that's why the noble gases have the highest ionization energy, because it's going to take a lot of energy in order to take electrons away from them. But over here, the alkali metals, they only have one valence electron, right? So they either have to gain 7 or just give that one away in order to be stable. So it's going to be easier for them to just give an electron away. So it's not going to take much energy in order for us to lose an electron if it's willing to just give it up automatically. So this is why we increase in ionization energy from left to right across our table. So how might this look in a problem that we're going to work out? So an example for this one may want us to put it in increasing order, and then gives us a list of elements. So let's say we have phosphorus, magnesium, chlorine, aluminum, and sodium. Alright, and I want to put these in increasing ionization energy order. Alright, so who's going to go first? We want the lowest one first, so who has the lowest? It would be Na. It's going to be the one that's furthest to the left. Alright, out of those, which one's going to come next? Magnesium. Alright, then we would run into aluminum. Alright, after aluminum, the next one that we have up there would be P. And who would have the greatest? Cl. Alright, everybody see how we got those letters and how we put them in order?